Today's lesson is dividing tens and hundreds. Before we do any division, I'd like to remind you that dividing is the opposite of multiplication. So strategies that we could use for multiplication is apply the opposite strategy in order to get the division answer of that. So let me remind you, during multiplication unit, we did work with tens and hundreds in order to find out the answer. So I'll be giving some examples with multiplication and work our way until we get the dividing answer of it. So 30 times 10 is equal to what? We used to always put the zeros to the side and multiply the numbers that are not zero. So 3 times 1 equals 3. How many zeros do I have remaining? I have 1 over here, 1 over here. So I'll bring them over and the answer will be equal to 300. Again, there are some errors that we used to use when it came to math language, and we would say 3 times 1 equals 3. I have 2 zeros remaining, so I will add that to the 3 and the answer is equal to 300. That is not correct, because 3 plus 0 equals 3. 3 plus 2 zeros equals still 3. But if I bring over the zeros, now the answer is going to be different, which is equal to 300. Another example over here is 40 times 60 equals what? I'm going to multiply 4 times 4. 4 times 6 equals 24. Bring over 2 zeros that we have over here, and the answer is 2,400. Another example is 7 times 30 is equal to what? 7 times 3 equals 21. And I bring over the 1 zero that we have, and the answer is equal to 210. Now I'm going to be using the opposite strategy of this, or the same exact strategy, but the opposite, which is dividing in order to get the answer. So 300 divided by 10 is equal to what? 3 divided by 1 equals 3. And now I would have to work on eliminations. I eliminate 0 with a 0 that we have over here. How many zeros do I have remaining? 1, so I bring it over. The answer is equal to 30. 2,400 divided by 60 is equal to what? Again, we work with 24 divided by 6 equals 4. How many zeros do I have to eliminate? If I have 1 here, eliminate the 0 over here. I don't have no more zeros to eliminate, so whatever 0 is remaining, I must bring over. Continue with another example. 210 divided by 30 is equal to what? 21 divided by 3 equals 7. How many zeros do I have to eliminate? If I have 1 here, it eliminates the 1 over here. I have no zeros to bring over, so the answer is equal to 7. Let me give you another example. 320 divided by 8 is equal to what? 32 divided by 8 equals 4. And let's see if we have any zeros to eliminate. I don't have no zeros on this side, so I cannot eliminate the 0 that's on that side. So I bring over the 0. The answer is equal to 40. Now, within this lesson, I could always ask you to use base 10 blocks to get the answer, or to get the answer of a dividing question or a division question. So, for example, over here, if I have 300, I could tell you, how can we represent 300 using base 10 blocks? Your answer could be, I could use 300 units. Again, just to remind you what a unit is those very small cubes, and each one represents 1. Or you could say I could use 30 tens. 30 tens are those rods. Each rod is worth 10, so each unit is worth 1. Each rod is worth 10. So 30 of these tens is equal to 300. How else can I represent that using base 10 blocks? You could basically just say I could use 30 flats. Each flat is worth 100. 300s is equal to 300, or 3 flats is equal to 300. I'm going to give you another example. 350. How can I represent 350 using base 10 blocks? Again, simply you could say 350 units or 350 ones. I could also say I could use 35 tens. Again, each rod is worth 1 10. So 35 tens is equal to 350. How else can I represent it? I could represent it by using 3 flats or hundreds, and I cannot use another flat. If I do, that would be 400. So I'd have to use 5 tens. Now, why am I using base 10 blocks in this lesson? I'm using base 10 blocks to show you that if I have a group of base 10 blocks and I divide it, I give some, or I split them up, what could the answer be? How much would everybody get? The reason why, again, that I'm using this is instead of saying 350, I could say 35. So instead of saying 350 divided by 5 is equal to what? I could say 35 tens is equal to what? Okay, 350 divided by 5, that's a big number. Again, it might get to us. If we use the strategy that we used earlier, we could put the 0 to the side, do 35 divided by 5. The answer is equal to 7. Bring the 0 over, the answer is equal to 70. But if I'm dealing with this, I could just say 35 tens divided by 5 is equal to what? It is equal to 35 divided by 5 equals 7. And we bring over the word tens, so equals 7 tens. 7 tens is the same thing as saying 70.